But there, the last time I went through basically, not this one here, I went through, which one's that? Go through downloads. Downloads, and as I believe I went through this set of slides here. Let me just kind of fly through them again, just that there. But I think these are the slides that I went through. Yeah, they don't look right. No, it wasn't these. Yeah, this one. Right there. Okay. Right there. Let me just kind of fly through and kind of hit the highlights again, just to repeat, since I didn't record on Wednesday. Right there. Yeah, I remember these were the slides because right there. Okay. The Raspberry Pi is the single board computer. I passed it around last time for you to look at. Right there. Today we're going to fire it up if I don't break the memory card again. That's there. So, that's there. And I'm going to kind of go through the steps on how the memory card is created, but you'll do that later as a lab, right there. So, it may be a few weeks before we get the boards, in which case we may go a little slow, because there's not a lot I can do until you get boards in your hands, right there. But, right there. So, the board was designed to promote the study of computer science, not electronics, but electrical and computer engineers have grabbed onto it a great deal. A competitor to the Raspberry Pi, and it's not really a competitor, it's a completely different board I'll talk about later in the hour, is the Arduino board. And some of you who have gone through 2-year programs have probably seen the Arduino board, right? That there. The Arduino board is a very popular board among students because it's so easy to use. It's so easy to use that we're not going to let students use it anymore for FYP. That's there. Because it's just a real simple board, and I'll pass this around later, and I talk about the difference between the two. That's covered on another slide. That's there. So there's been a lot of these sold. It's on version 3, right there. These slides only talk up to version 2. You know, there's a version, the original Raspberry Pi, then the Raspberry Pi B, then the Raspberry Pi 2, and then the 2B. This is a 2 right there. I've ordered, what I've got on order is the 3. Then I guess in 6 months the 3B will be out. Right there. They keep coming up with new ones every time. Right there. It's very low cost. Right there. We're talking roughly $35 US a board. The boards that I bought were 170 ringgits. 170 ringgits. Right there today. Where is my money changer? There's my money changer. So 170 ringgits is 38 USD. So it's still in the same price range. It's gone up in, yeah, of course I don't know if that's the right, that I haven't updated that for a while. It hasn't gone up very much in prices in USD, but it has gone up quite a bit in RM over the last year and a half. But that's a function of the RM going down in value in comparison to other currencies. So you know, so I paid, you know, the current boards are 170 ringgits. They were about 140 ringgits when I bought the Model 2 about a year and a half ago. About that there, but the RM was more like 4.2 something. Now it's 4.45, I think, something like that there. So here they're looking at, this is the 3 original models right there. Again, you can see that the 3 original models kept the same amount of RAM there. So, I mean, there. And actually the Model 2 kept the same amount of RAM. The Model 3 is gone to 1 gig of RAM. I mentioned that the other day. The storage from the Model B to the Model B Plus went to the micro SD card instead of the SD card. I almost would prefer they stayed with the SD card because they're easier to not break, and they're also a little bit more substantial to carry. I tend to lose these little micro SD cards. I don't know. My phone takes them and my tablet takes them, and my computer here takes one. That's this little laptop actually doesn't have a hard drive. It has a micro SD slot. So if I want to change that there's no CD-ROMs or anything else on it. It just uses micro SD as the only that there. So there, it has 40 general purpose I/O right there. That's a picture of the Model A, Model B, and the B Plus, and the 2 and the 3 look almost identical to the B Plus. They really haven't changed much in terms of the looks right there. And as I said before, technical specs, these are wrong in the fact that they're the big difference between the 2 and the 3, and this is a huge improvement in my personal opinion, is that they've added Wi-Fi. That's there. So the boards that we'll be working with have the Wi-Fi built in. You don't have to tether to an Ethernet connector. Actually, what most people did with the Model 2 and the 2B is they actually plugged in a Wi-Fi USB adapter in order to give it Wi-Fi. They've since added that to the card itself, right there. So I'm going to go through how Raspberry is installed today, right there. So the PC, as I said before, the Raspberry Pi equals a PC. You may not think so, but if you go historically and you look at older PCs, the Raspberry Pi actually is very favorable to the earlier PCs, actually even up to 10 years ago, right there. So when we look at a Raspberry Pi and a PC today, we can see that there's some differences. I went through this slide last time. That's there. So, but that was the slides I went through last time. Now, that's there. What was that? Oh. That there. This is from a workshop, and I don't think there was 1 or 2 slides that. Oh, this is the one slide I wanted to go through. I knew that there was a reason I kept this one up here. The Arduino Uno, which is this board here. I'll just pass it around right here. You can see it's a smaller board. It basically has one chip on it there. It does have a little chip here for the programmer right there, and it's got a crystal to drive the chip itself right there. It's got a voltage regulator on this side here, and that's pretty much all there is on this particular chip right there. And then you've got the I/O connectors on the side right there. So we'll start here. Just kind of this there. The Arduino is very much like the 8051, only less powerful than the 8051 right there. And it's a very popular chip with, I think we've got some students who are either sneaking, whether or not they want to come in late or whether they're just sticking their head in the, looking in that there and clap and making fun of us, right? Right there. The Arduino is actually a microcontroller. The Raspberry Pi actually has a microprocessor, and we're using it as a microcontroller as a board itself. It's actually a full-blown microprocessor. The ARM processor, which I'm not prepared to talk about today, has 2 different families. One is the microcontroller family, and the other is the microprocessor family, right there. And the Arduino and the Raspberry Pi are both based on ARM processors, right there. And the ARM processor is actually from the old Acorn Computer Group out of the UK as well, right there. And ARM does not make microprocessors or microcontrollers. All they do is develop specifications and actually Verilog models for these particular microprocessors and in the cores, and they're made by different companies. There, Atmel makes a number of them. I'm not sure who. Atmel actually makes the one for the Arduino. I'm not sure who makes the one for the Pi. There, it may also be Atmel. It could be another company. I have not looked at my Pi, and my eyes are not good enough to read that processor name on that there. It's not Atmel, I can tell that because it's got a looks like Qualcomm or something like that. I can't read who makes the processor. I wouldn't be surprised if there's not multiple companies making processors for the Pi, but the Arduino I know is an Atmel processor. It's a Mega processor. Right there. The Arduino is operated without an operating system. That there, so it's completely run headless in terms of the fact that we don't have a monitor, keyboard, or mouse for it. We have to write all the code for the Arduino on a PC, compile it, and then download it to the Arduino and run it on the Arduino. Same as the 8051 that you did in the microprocessor class. That there. So it's that there. The Raspberry Pi runs a version of Linux right there, and it does run a version of Windows 10, the Internet on Things version of it. It's it's a watered down version of Linux that there. And I shouldn't say it's not very well watered down. It's pretty much a complete version of that there. Speed wise, the Arduino runs at 16 megahertz. It's actually faster than the 8051. The 8051 is an older processor right there. The Raspberry Pi, the Model B that there runs at 700 megahertz. I'm thinking that it's up to 1 gigahertz. It might be even 1.2 gigahertz. The Model 3. I'll look that up here in a little bit. There. So RAM. There's only 2K of RAM on the 80 or on the Arduino. That's not a whole lot of RAM. Right there. 2K. When we were looking at the 8051, we're looking at about 1K, right? So, of RAM. Actually, it's got 64K of program memory, and I'm not sure how much K. I think it's 4K of RAM, depending on which model that they're. The Arduino or the Raspberry Pi's got a gig of RAM, the new model. The other key difference is there's no graphical output from the Arduino or the 8051. The only thing you've got coming out, if you program it, is a serial to a terminal right there. So it does have a serial port, and you can run a program called PuTTY right there, which we didn't do. I don't think you did that in your 8051 course. I should have added that to the course, doing a serial lab there. But regardless, there is no input or output in terms of keyboard, mouse, and display. The Raspberry Pi has a full user interface right there. So there, the general purpose I/O pins right there. The Raspberry or the Arduino I just passed around has 14 digital pins, of which 6 could be used for analog. Now, the one big downfall of the Pi is there is no analog, and I think I mentioned that last hour right there. There is no analog. Other connectivity, there is no other connectivity on the Arduino. You got the SPI serial interface that you can connect to it right there for doing serial communications up there. So the Raspberry Pi's got USB, Ethernet, Wi-Fi. The Model 3 has added Bluetooth that there. So we've got all kinds of options on that there. So power consumption, it's a 10-to-1. You know, the Raspberry Pi uses a lot more power. But 3.5 watts is not a lot of power in terms of scope of things out there. A standard incandescent light bulb, which we don't use anymore, uses about 60 watts to 100 watts of power. A fluorescent light like this uses 40 watts right there. The little incandescent bulbs that you use, what do they call them here out there? But the little fluorescent light bulbs, they typically run about 15 watts or so. And then the LED bulbs are somewhere between 8 or 9 watts. So these actually run a lot less than a light bulb right there. So an air conditioner runs 1,000 watts, so 3.5 watts is nothing. A desktop computer typically will have a 400 watt power supply, of which is maybe 70% efficient. So you take 600 watts to run a desktop computer right there. So, okay, operating systems right there. So I'm going to go ahead and talk a little bit about this and then go through the little demo. We have an operating system available right there, and it's a giant piece of software that allows you to write programs, download there. It does all the interface with the real world, so you don't have to right there. If you want to talk to something with the Arduino, you write the software to talk to that particular port. If you have an operating system, then you run things through the operating system right there. So almost every computer system out there today being used has some form of operating system. The most common operating system out there is Windows, right? That there. That there. Mac OS is the other desktop operating system, and then Linux is another one right there. There are two types there. There are closed, which means that a particular company owns that operating system and sells it. And then there's Linux, which is open source, which basically means that the kernel is put out on the internet. Anybody can download the Linux source code, modify it, come up with a new version of Linux, distribute it, give it away, that there, sell it, whatever you want to do with it. It's free. It's free for the taking. It's free and legal. That they're not like the Battalion Street software vendors. That there. I don't know Battalion Street, they still sell software disks or not, but I think most of you understand what I mean when I say the Battalion Street software vendors. That there. You? Pirated software, yeah. There was a shop or mall near Loyola. What was it? MB Plaza that used to sell a lot of that. Yeah, MB. Okay, that there. But Linux is actually open source, and there's a whole family of software packages out there that are open source that are free for the taking, and you can use them without purchasing anything. It's perfectly legal. That there, and that's called open source software. That there, and Linux falls under that category of open source. You don't pay anybody for Linux unless you want support. And normally, if you pay for Linux, what you're paying for is a phone number to call when you get in trouble, right there, or a packaging that's been certified and tested. Typically, one of the problems with open source software is that you get what you pay for in terms of it hasn't been thoroughly tested, it hasn't been debugged. If it doesn't work, there's nobody that you can sue and yell at because you didn't pay for it. It was free. A lot of companies are scared of that. They want somebody to point their finger to and yell at, right there, when things don't work. So it's kind of a mixed bag. Which one do you go with? Right there. Okay, the Raspberry Pi. We're getting into the actual workings of the Pi. And where did I put my Pi? Here's my Pi. Let me go ahead and just tear it down here. The memory card is in the back of the Pi, right there. We'll be careful not to break this one, right there. And actually, I was going to program another memory card, and I just stuffed it underneath the board, right there. But I didn't bring my little programmer with me, that's there. So I'm not going to bother with that there. But let me grab the internet here. I find me and Wi-Fi don't always get along in this building. That there. I know you guys probably got the Wi-Fi all figured out, right? Here, up there, but I don't always remember my password and all that stuff. And I'm getting to be an old man. Everyone in the office agrees that I'm the old man in the office up there. So, but I also remind them that I remember more things than most of them do. You know, the old saying is I remember more about up there. Okay. There's a okay. There's a program out there, or a package called Knobs, N-O-O-B-S, right there. And Knobs is a installer for the Raspberry Pi, right there. And you can download it from the raspberrypi.org site, right there. And right there. Now, when you download Knobs, there's two versions. I would just simply, we'll use the full version of Knobs right there. And it's a 4 gigabyte file right there. Yeah, I think it's 4 gigabytes. Download the zip file, the online and network install, right there. Yeah, it's 1.1 gigabytes right there for the full version. That there, and it's a zip file with a number of files on it. And basically, all you do is you reformat a micro SD card. I was going to go through this step, but I left my micro SD card adapter in the office, and it's a wasted step to go through. Formatting a micro SD card and copying the files over to it is fairly that's there. Once you've done that, then you basically take the micro SD card and you plug it into the board right there. Now, when you bring up the board the first time, you'll go through an installation procedure. I'm going to skip that. It takes like 10 minutes. It's not worth our time for you to sit there and watch the computer go through and show that there. And once that's done, it's ready to reboot. So I'm going to go ahead at this point. First thing I'm going to do is stop the recording, because I'm going to stop talking to the slides right there. Right there.